Feedback is another concept very fundamental to systems thinking, so I'm going to spend a few minutes and talk about feedback. In the definition of a system, talked about um, the system maintaining its existence through the mutual interaction of its parts. And the diagram was drawn in such a way that A influences B and B influences A. And and the line between the two is really just intended to imply an influence. Though what happens, though feedback is the result of an influence, so that A has an influence on B, and as a result of that influence, B has some influence back on A, and it's that reciprocal influence that is in fact considered feedback. So one element's feedback, one element's action is another element's feedback. So what is feedback depends upon where you're looking at the influences from. So that if I start from B and say that B has an influence on A, the result of that is in fact the feedback from A back to B. And feedback comes in two different types, positive and negative, or reinforcing or balancing, and that is defined in terms of the implication or the effect of the reciprocal interaction, so that if A adds to or influences B to increase, B can then influence A to increase or decrease. If it influences A to increase, it's called positive or reinforcing feedback. If it then influences B to A to decrease, it's called negative or balancing feedback. Now it's a little bit easier to get a sense of in these causal loop diagrams, which are meant they're just general diagrams meant to represent savings account in a situation where things are changing. And there are separate videos about causal loop diagrams and stock and flow models, which I'll talk about in a moment. But in a reinforcing construct, the principal in a savings account interacts with the interest rate to create an interest, and the interest then actually adds or increases the principal. So the principal adds to, through its interaction with interest, adds to interest, so it's reinforcing. And the interest is then periodically added back into the principal, so that's also reinforcing. So both of these interactions are reinforcing, and this is referred to as a growth loop. And the note, don't worry about the notation, it's covered in the causal loop diagrams video. Simply wanted to point out the fact that here is a structure within which all of the interactions are reinforcing. The alternative being this change situation where there is some perceived goal that one is attempting to attain, and there is some current state that exists at the same time, and it is in fact the difference between those two which represents a gap and is an impetus for action, and the action is meant to move the current state in the direction of the goal. So the influence between the current state and the action is meant to be balancing, because it's the distance between these two is responsible for the amount of the action, and the action then adds to the current state. And as the current state moves closer and closer to the goal, the difference between of them gets smaller and smaller, and the action becomes less and less. So this is considered a balancing structure. Now, causal loop diagrams are qualitative depictions of relationships in systems to really get a sense of the implications of those interactions. We do simulations, and we do them with stock and flow models. Here are the stock and flow equivalents of the two causal loop diagrams previous. And the diagrams are very similar, except that the relationships one develops between the components are much more explicit. I mean, they're very exacting rules that one has to to follow in terms of putting these elements together, and the elements themselves also have formulas associated with all of the connections, all of the interactions, so that one can then actually simulate the models to get a sense of what the real implications of the interactions are, so that here in this savings account, this growth loop with an initial value of, I don't know, 5% for the interest rate and the principal starting out at $100 over a period of 10 years with 5% interest. This grows from 100 to out to about 162, which is not a very rapid rate of growth because it's a very small interest rate and it doesn't grow very rapidly. But if I were to in fact alter this to which is a very unrealistic interest rate, but if I go ahead and make this, let me make this 0.5 and run it again just to give you a sense of what an exponential curve looks like. This starts at 100 and ends at 11,000 and something after 10 years, and it's simply by changing the nature of this interaction and the way this reinforcing structure interacts. So though from the principal's perspective, interest is feedback, and from interest perspective, principal is feedback. And in the case of the other structure, the current state, action is feedback, and from action's perspective, the current state is the feedback and tends to balance it. If we look at this structure over the same period of time, the goal was 100 and the current state started at 0, so that the current state, which you can see by this line, started at 0 and continued to increase, though over time it increases more and more slowly as it approaches the goal. So I wanted to go ahead and use simulation models so that you could actually see the implications of the feedback, where this feedback has a tendency to create exponential growth, and the balancing feedback, in fact, tends to cause the structure to approach a balance. And those are the two of them. So regardless of the model, regardless of how complex the model is, it's simply composed of a number of elements and some number of influences, those influences either being reinforcing or balancing influences. So see you in the next video. Hope this has been informative.